put little notes as we go through this for yourself, so you know what's going on for tomorrow. Tomorrow, even though we have a full period to do this, it's probably going to take you most of the period to do this, probably, because it's the first time you're going to be doing it, of course. So we need to keep that in mind as well. So we're going to look at titrations today. Titrations is basically just solution stoichiometry, and it involves the continuous addition of solution from what we call a burette, and I'll show you all this stuff as we go through it over here. And so I'll kind of refer back to these terms here as we go through here, but into a measured volume of another solution. One of the two solutions must be a standard solution. What is a standard solution from Unit 3? What's a definition of a standard solution? What is it? Somebody, come on. Standard solution. We would make a standard solution in a volumetric flask. What is this definition of that, though? Yeah. You know the concentration. So you have to accurately know the concentration. Okay? So we have to know the concentration of one of the two solutions if we're going to do a titration. The purpose of a titration is always, and this will be your lab tomorrow, guys. If you want to pay attention right now, I'll tell you what the problem is. The purpose of the titration is always to find the missing concentration of the other solution. Okay? So you're going to use stoichiometric calculations to standardize the other solution, to find out or determine the unknown concentration. Always. Okay? That is the purpose of a titration, to find the unknown concentration. We'll have two solutions. I'll know one. You have to find the other. Okay? So we're going to use stoichiometry to calculate, or basically to standardize, the other unknown concentration. All right? Now, a couple definitions you'll need to know. First of all, the titrant. The titrant is whatever we put into the burette, and the burette I'll show you in a second here. That's the solution in the burette. There is another one that's not on here, so you have to put this in. It's called the aliquot, A-L-I-Q-U-O-T. Okay, and it is the measured solution, measured volume of solution we place under the burette. So it's going to go underneath the burette. Okay, and once again, I'll show you this in a second here. It is the measured volume of solution we place underneath the burette. Okay. Now, I'm not going to ask you to define a titrant or burette, but I will ask you which one is the titrant and which one is the aliquot. Okay. So you need to know where they are in relation to each other. So titrant, aliquot. Titrant's the solution in the burette. Aliquot is the solution, basically. It's a measured out solution. It goes underneath the burette. Okay. You're going to use what we call a burette to record the volume of the titrant required to basically, well, neutralize. Okay. Most of the time that we do these are acid-base titrations, and what we need to do is we need to be able to find that point where they neutralize each other out. Okay. To do that, you're going to use an indicator. Now, the indicators that we're going to use are going to be phenolphthalein or bromothymol blue. I'll tell you for tomorrow we're going to use phenolphthalein, and that's the one I picked here for you so you can kind of see the color change for that. There's going to be, the indicator changes color to show that the reaction is complete. Okay? Two definitions that go with that are the following. Endpoint. You have to know these definitions as well. So this might be just a straight definition for these two here on Unit 4 test for the final exam. So the endpoint is the sudden change of color. It is what we would consider a qualitative observation. Okay, the quality, the sudden change of color. That is the endpoint. Okay, so sudden change of color. The equivalence point, this would be your qualitative. That's not spelled right. Qualitative. I don't know. Qualitative. Anyway, qualitative. Okay. Observation. The equivalence point is the quantitative number. Okay. So it is the actual. See if I can spell this. Quantitative observation. It is the actual volume, the measured volume that is required to reach that sudden color change. Okay. So please know those two definitions. All right. And I'll try to remember to use them today here. I don't think I did a good job of that in period 1 here. Okay. So good. All right. We're going to hop right into our example here, and I'll do the demonstration at the same time here. Our first example here, before we get to that, this is very important as well here, and I'll refer back to this in a second here. For each reaction, you need to do a series of trials or a series of experiments. We have to make sure that we're being accurate with this. So we usually, for that to be required, we take a minimum of 3 trials or 3 observations or 3 experiments. Okay. Those 3 trials, some key words here, you need at least 3 of them, and they have to be within a range of 0.2. Okay. So you need at least 3 trials, and they have to be within a range of 0.2. All right. And then we will calculate the average volume of the titrant required to do that. Okay, so here we go. So let's take a look at what a titration actually looks like. Titrations are very, very common. You'll probably do 3 or 4 next year. And you will probably, in fact, they're doing one right now in Chem 30. And you're probably going to do probably about 125 in university. Okay, so very, very common. I made up that number. I don't know how many they do. But very common. Okay. Here's your burette here. Okay. It is basically, it's got 0 at the top here and 50 down at the bottom here. So it's a 50 milliliter burette. There's bigger ones, there's smaller ones, whatever. But 0 to 50. That's in milliliters. So make sure you take note of all this stuff. Make sure you write down some notes for yourself today, because when we get there tomorrow, you have to be ready to go. Okay. It's got a valve at the bottom, so 0 to 50 milliliters. It's got a valve at the bottom. If it's in line like it is right now, it's open. So anything that's in here will drain out. And to close it, you will turn it horizontally, of course. This valve goes both ways. So open, right, closed, open, closed kind of thing. So either way you want to turn it, doesn't matter. Stuff's going to come out. Okay. So if you're turning it this way or this way, stuff's going to come out. You need to be careful of that, because it's easy to go the wrong way when you're trying to be very precise. So let's say you're going very slowly right now and you decide that you want to turn it off. People panic and they turn it like this, and then a whole bunch of stuff comes out, and that basically ruins it for you. Okay, so make sure you know which way you need to turn it off. Okay, to put it into your burette holder here, you're just going to push back the middle tab. You can do either one here on either side, and just slide it in there like so. Okay, I'm going to get this out of the way here. Okay, so that's your burette, and you need a holder for that, of course. We're going to look at this titration here today. It's 10 milliliters of HCl with, I actually changed this number here, so let's go ahead and change this right now. It's 0.10 moles per liter sodium hydroxide. So go ahead and change that, please, so you know, so these numbers make sense once we write them down here. What I want you guys to do first is I want you guys to write out this equation. We're going to be mixing these two together to neutralize the acid or the base here. So write down a reaction for me that involves hydrochloric acid and sodium hydroxide. Write that equation out, and I want you to balance it, etc., etc. Okay? Okay, so equation, right? Hydrochloric acid, sodium hydroxide, double replacement reaction. This is an acid base. It's actually a special type of neutralization. It's called the special type of double replacement called neutralization, right? Acid base, salt, and water. Yes, always. Okay. So we got this here. You're going to look up here and you're going to write down the information they give you, just like with any other stoichiometry question, and you're going to put it in the right spot. So we have 10 milliliters of hydrochloric acid with 0.10 molar sodium hydroxide. So we're going to go ahead and put that in there, right? Let's see here. So we had 10 milliliters of hydrochloric acid. Going to change it to liters, of course, because my formula does liters, remember, C equals N over V. And over here, we have our concentration, 0.10 molar. And that's all I know so far. Okay? Are basically those two things there. Okay, that's all I'm told in this question, or in this problem here. All right? So, remember, the purpose of any titration is to what we call standardize, to accurately know the other concentration. So what am I looking for? I'm looking for that right there. What is that? What is the concentration of the hydrochloric acid? Okay? So, to do that, we're going to use titrations. Okay? So, here's my burette here. Okay? Whatever I decide to put into this is going to be called the titrant. So anything that I put into here is called the titrant. If I put the acid into there, that's the titrant. If I put the base into there, that's the titrant. Okay? This is always the titrant. Always. Okay? Underneath here, I'm going to set up a little flask, and whatever I put into the bottom there is going to be what we call the aliquot. Always. Okay? So always the aliquot down here, always the titrant here. Okay? Now if I put the acid up here, the base is going down there. If I put the base up here, the acid goes down there. We have to mix the two together. We're going to do that by running solution through here and catching it in the bottom and making those two solutions react together. Okay? Good so far? Now, what do we want to put where? Well, does it matter? Well, it does, kind of. Okay? In this particular question, it does matter because I've told you that we're going to use 10 milliliters of hydrochloric acid. Okay? So, we're not going to put the acid up here because this measures volume for me. Okay? So you'll kind of understand once we get a little bit further. I have a measured volume. I want that to be my aliquot. So I want to put 10 milliliters into here of acid. Okay? Now, is it possible to switch this experiment around? And the answer is, oh yes it is. Okay? And I'll give you some examples later on how you can switch stuff around and you can still find information that you need. Okay? It is very important with the titration to make sure that we know what's going where. Okay? In this particular case, like I said, we're going to take 10 milliliters of hydrochloric acid. I want that to be my aliquot. It's a measured volume. I already have that measurement. I want to put it into here. To get that hydrochloric acid into there, you will use a volumetric pipette, the best thing to use. Now, the other question is, do I have to use 10? In this question, yes. Is it always 10? Pretty common, yes. Doesn't have to be. It could be 25, could be 50, could be 15.5 if you want. It doesn't matter. But this is a volumetric pipette. It's very good at doing 10. Okay? And that's what you guys are going to use tomorrow as well. So in this particular question, yes, we want to use this 10 milliliters of acid. You will do pipetting tomorrow, so good practice for you here. Here's my hydrochloric acid. Maybe we'll just put it over here. You will squeeze the bulb. Okay. You won't have, I'm going to give you a different looking beaker tomorrow here, so you won't have to worry about this, but squeeze the bulb, put it on top here, and you're going to draw up 10 milliliters of acid here, hopefully. Okay. Put your thumb on top. Remember, let's maybe not use our mouse to suck this up. It is acid. Okay. Now, the line that you want to get to here, I kind of missed it a little bit. We'll pretend. The line that you want to get to is right. I seem to be losing some for some reason. Okay. The line that you need to get is right here. Okay, not this orange one here. I don't know what that is. That's just a decorative thing. There's a little skinny line right here. That's the one you need to find tomorrow. Okay, so let me just try this again here. I don't want to gyp you guys at the full experience here. Looks good. All right, where are we here? The bubble is going to be incredibly tiny, and it's very, very accurate. And the most important thing with the titration is that you do it consistently every time. So 10 milliliters of acid, and you will put that into an Erlenmeyer flask, 10 milliliters of acid. So that is me measuring out this right here, the hydrochloric acid. Okay? And remember, don't blow on it. That's called natural selection. Okay? Don't put the bulb on it and try and get every last drop out, because it's not going to. It's calibrated that way. If there's a little drop in there, that's fine. Here comes one more, I guess. Maybe. Maybe not. Come on. There. Okay? There might be a little bit left in there. Don't forget that's how it's calibrated. Okay? So 10 milliliters of acid. Okay? So I have that part set up. Now, if my acid's going down here, this is my aliquot. What needs to go in the burette? Well, the sodium hydroxide, of course. That will be my titrant. Okay? So you will grab a funnel. Okay? You'll grab some sodium hydroxide, and once again, I'll give you a little beaker for that tomorrow. Okay? And you will fill up the burette with sodium hydroxide in this case. Now, could these be switched around? And the answer is yes, but we'll worry about that later. Okay? If you do it like this, it's not a good idea. So if you just start pouring like this, what happens is there's no air that gets in there, so it starts to back up, and you'll get this whole funnel filled up with sodium hydroxide. And it's going to start pouring into here, and you're going to keep pouring and pouring, and then eventually it's going to get closer and closer to the top, but this is still going to be full, and that's bad, because at some point in time it's going to leak out. And usually when it leaks out, it makes a huge mess. It's not only going to go over the burette, you're going to have sodium hydroxide, which of course is very dangerous to you. And it's going to go on the table. We're going to have to wipe it up, etc., etc. Okay? So be very careful, and don't do that. The worst thing, you know, obviously the stuff we're using is not very high strength, but nonetheless, what happens is it leaks over the side here, and if you don't get every last drop cleaned up, it will leak. It'll eventually get onto the tip and get into your solution, but it's going to affect your results. Okay? So what I suggest is you take your fingers and you just put them on top of here, like so, and that just creates a little bit of an air break there for it, and you can just simply dump in the sodium hydroxide. Obviously, make sure the valve is closed, otherwise it just leaks out the bottom. And we have the same kind of problem as before. You need to fill it up past 0. Okay? Past 0. So make sure you guys write this stuff down. You have to fill up the titrant always. I don't care what it is. You always have to fill it up past 0. So the 0 marks down here, guys, you have to fill it up past there. All right? And now you're just going to simply lift this up here. And the reason you fill it up past 0 is because you'll actually, it'll be hard for you guys to see, but you'll see this tomorrow, I promise. And you can just simply pour that back into the one that you used. So I'm going to give you extra sodium, or I'll give you extra whatever tomorrow, and you can just simply pour it back into the same container. Make sure you keep them straight tomorrow. But what happens is, in the tip here, there is no solution at all, because this valve has stopped the solution. So right here at the bottom, right here, there is no solution in there. If I turn it on right now, you know what happens? Solution starts to move, but nothing coming out the bottom. Okay? So when we go to do our first experiment, I'm going to be measuring a volume, but nothing's coming out. Okay? And that's bad. So we need to fill it up past 0 to get rid of this air in here. Okay? So I'm going to turn it on. When you turn this one on, make sure you turn it on full strength, all the way. Open it right up to force all the air out. Okay, so here's me, and turn the valve on full way, okay, and let it go. And then once you get closer to zero, you can stop it. And what you'll see tomorrow is actually the air bubbles being forced out the bottom here. Now the tip is filled with my titrant, yes, and I need to get it down to zero now. So let's see here. Good. Okay. So sodium hydroxide here. Okay. That's my titrant. My aliquot is here. This is still my acid. I need to mix the two together. 10 milliliters of acid, check. Got my 0.10 molar solution, sodium hydroxide, titrant, here, check. If I mix the two together, what do you get? This and this, right? Are you going to see sodium chloride being formed? No, because it's aqueous, yeah? Are you going to see water being formed? That looks like water to me too, doesn't it? It's acid, but obviously there's some water in there. So you can't forget the indicator, because otherwise you'll see nothing. Okay? So 2 drops of indicator is all that you need. Maybe even 1 drop would be enough, but usually we say 2. Okay, so here you go. 2 drops of indicator. You don't have to squeeze it. Just tilt it over. 1, 2. There you go. Now, indicators have many different colors. You guys saw that with the spot plate stuff, yes? Okay, when you did the spot plates, remember? There's lots of different indicators. They all have different colors. Phenolphthalein in acid is clear. Okay? Phenolphthalein in a base is a pretty pink. Okay? I picked this one just for the girls tomorrow. Okay? So it's a pretty pink. Well, look, if our job is to get this perfectly, if I mix the right amount with this and the right amount of this exactly, if I mix it clear, right, with pink, I get this and this. What color would this be? Is this acid or a base? Sodium chloride, is that an acid or a base? Neutral, right? Ionic compound, neutral. What about water? Acid or base? Neutral, right? So if I mix this perfectly, clear and pink, what's the halfway color between clear and pink? Purple? No. Yellow? No. Clear and pink? Light pink. That was a trick question. Light pink is between clear and pink. All right? Light pink. Girls, you should know this, eh? You girls know like things like fuchsia and maroon and colors stuff. I don't know. What other color? Mauve. I don't even know what that is. I don't know. Teal. Eh? Anyway, so you should get a light pink. All right? So here we go. Acid with indicator. Aliquot. Okay. Titrant with my base. Okay. Here. And you guys can come closer now. Come closer. Come here. Come here. Hurry. No, don't give me that. When I add some color to, or when I add some base to this, you're going to see, okay, you see it's changing pink there, okay. Now, what's happening is the base that I'm adding is reacting with the indicator at that specific point, and it is turning pink, of course, because bases with the indicator are pink. However, okay, it is not completely, the base, I haven't added enough base yet to neutralize all the acid. So if you swirl it up a little bit, it disappears because now the base is distributed throughout the entire solution. Okay? So you're going to add a little bit more base. And you're going to stop. And you're going to mix it up, and it goes away. Okay? So we're not at that point yet. We're going to add a little bit more. And I'm going to swirl it up, and it's going to go away. Now, don't panic tomorrow. Listen, if you start adding some solution from the, if you start adding some titrant and nothing happens, the first thing you should say, did I add the indicator? Because if you didn't, then you probably should stop and do that right away. But if nothing happens, that's okay, because it may require a lot of the titrant to actually start to change that color. Okay, so I'm going to add a little bit more here. We're going to stop. See, it's turning pink, so I want to kind of stop when it starts turning pink like that and just swish it up and it goes away. I'm getting probably a little bit close here, I would say. Okay, when it starts to turn pink like this, it's going to be fairly close here somewhere. Notice I'm not looking at the numbers right now. I don't care about that. You need to get the end point, right? That sudden change in color. Ooh. Okay, well, there you go. So, the answer to this is, there's my first experiment. It's done. Okay, this, so you guys can see, is probably a little too dark. Okay, that kind of looks like, well, just basically a base. All right, so what's actually happened here, I've added too much base into here. I've neutralized all the acid, and I got a little bit of extra base left over, right? Because it's too pink. So we want a nice light pink. Now, there's a couple reasons that this happens with today's experiment. One, I wanted to show you the proper color. So this, I wanted to show you the clear pink thing. Two, the acid and the base that I'm using, this is not the best indicator for it. You'll learn about that in Chem 30. There's different indicators that do different pH ranges. This is not the best for that. Okay, so that's another reason. So hopefully tomorrow we can get that nice light pink. Okay, and if you don't, well, as long as you're consistently bad, then that's all that matters. Okay, I don't know how else to say it. But this is too dark. We're looking for something. I'll kind of show you tomorrow. Hopefully, we're looking for that clear color with a slight hue of pink. Okay. Okay. So, too dark, but that's okay. All right. Go sit down for a sec. Now, we started this titration at 0. So we're going to put that in here. And don't forget, this is in milliliters here. So we started this titration at 0. And now I'm going to look at my actual number here. And you're going to be pretty precise with this, guys, as precise as you can. And I would say we're down to about 5.4 milliliters. And of course, so how much is the equivalence point? How much did I actually add of the base? Well, I started 0, went to 5.4, so 5.4 milliliters was used, okay? And that was our first experiment. Now, we have to be able to duplicate this. So, is it really 5.4? I don't know. It looked a little dark to me, so maybe probably a little bit less. But we have to be able to get at least 3 trials that are pretty close, okay? So, are we going to fill it back up to 0? No, we got this whole tube here. So now, I'm just going to simply start the next trial at 5.4, because that's where it is right now, right? That's where it's left off. So I'm going to start the next trial, my next experiment, at 5.4. You're going to grab another Erlenmeyer flask, okay? Another clean one, of course. And you're going to do this experiment again. So you're going to get another 10 milliliters of acid, hopefully. If I have enough acid here. I do, but the problem is getting it. All right, so we got our 10 milliliters of acid. Don't forget the indicator, 2 drops. Make sure the drops go down the middle, 2, right into the middle here. If they go along the side, that doesn't count, because they're on the side. You're not going to see anything. It's going to go too far, and you're not going to get the measurements that you need there. Okay, stir it up a little bit, put it underneath here. Now, the second time you do this, usually it takes you 4 trials to do this, because the first one is a ballpark number. Okay? I'm telling you right now, guys, if you're going to take the first one and you're going to try and do it really slowly and very accurately, it's going to take you forever, because look, it's about 5.4 milliliters. Tomorrow, it's not going to be 5.4. It could be 10, it could be 20, 15, 12 and a half, it could be 30, could be 40. It might take this entire tube. When you go to university, it might take you 3 tubes of this before you figure out the equivalence point. Okay? So you don't want to be going slowly, because you'll have you'll be doing that all day. Labs are 4 hours at university, right? You don't want to be spending time at 4 hours. That's a long time. So you want to get through this. You want to get a ballpark number. And then after is when you want to be very careful. Okay? I'll tell you this. Every drop that you let go out of this burette here is about 0.1 of a milliliter. And you need to be within 2 drops every time. Okay? Within 2 drops. So it's not a lot of error. Right? Now, look. I know it's about 5.4, roughly. Probably maybe a little bit too much, because it's a little too dark. But I'm pretty confident that I could probably add, let's say, if it's 5, let's say it's even 5, maybe I went 0.4 over, I don't know. But even 0.4 over, that'd be like about 4 drops. And I don't think that happened. But I could probably add 4.5 milliliters very quickly, yes? And probably be still safe. So what I'm going to do is I'm going to drop this. I'm not going to worry about the color. I'm going to say, let's go 4.5. If I went to 4.5, this would be about, what, 9.9, yes? I should be able to go to 9.9 pretty quickly and safely. So I'm going to turn this around here so I can see the numbers. Don't worry about the color for right now. And I'm going to go down to about 9, let's say 10. 10 should be fine. 9.9, 10. Boom, right about there. Okay? So I should be able to add that very quickly. And if I stir this up, it should be gone. Okay? And it is. So I've taken that part very quickly. The next part is very slowly. Okay? You're going to do drop by drop. Okay? So you're going to turn this on until you get like a little drop thing happening here. So very slowly, there's a drop. Drop, drop, okay? And you're going to stir it. Oh, by the way, another tip for you tomorrow. Put a piece of white paper underneath the aliquot. White paper allows you to see that color change a lot better, because the lab benches are black. Oh, we're getting really close here. Ooh. I probably need that 1 drop. There we go. Oh, okay, so we're really, really close here. We need to go drop by drop. So if you want to stop it at this point and go 1 drop, turn it off, 1 drop, turn it off. Make sure you know which way is off. Because if you go 1 drop and then you panic and you go like this and that opens it up, not good. It'll be pink in a hurry, okay? And then I hear, oh, right? So make sure you know which way off is. I kind of got 2 drops there. Come on. And I kind of need to get rid of this drop here, because if I don't, that drop's not in the burette anymore. So I got 2 drops on this one. Come on. The other thing you don't want to do is you don't want to put it on the side. So don't take the flask and kind of put it on the side, because it's not going down into the solution. Okay. So if at all, well, don't do that. Okay. Now this is going to be tricky. This is obviously too pink. I probably needed that 1 drop. Unfortunately, I got 2 out of that one there. So once again, probably a little too pink. But now you look at the numbers. Okay. And we got about 10 point. Ooh. Gonna go at 10.7 on this one. And that's a difference of 5.3. Okay? And now, okay, well that's still okay. It's kind of Same kind of number there, right? I'm thinking 5.3 was a little bit too much, so maybe 5.2, right? But it's hard to say, like I said. We'll have to see what happens on the next one here. So once again, you're looking right around that area. I could probably pretty safely add 5 this time, I think, and probably get away with that. So down to about 15.7 very quickly on the next one here. Same thing, you're going to get, hopefully, you're going to get 10 milliliters of acid. I should have 10 left over here, so the problem is going to be to get this out. How can I do this? Consistent with that. All right. And once again here, so we got 10.7. Probably 5 is going to be really safe, so I'm going to add. I'm going to go to 15.7 this time here. So let's see here. Where's 15.7? Kind of find 15.7 so you don't overshoot it here. Let's see. About there somewhere. Okay. Ooh, that was pretty close. That one, it took a lot of shaking for the color to disappear, so you know that it's getting very, very close. Okay. You're going to go drop by drop here, and since it's so close, I'm going to have to do probably 1 drop and stop kind of thing. So just got to turn this ever so slowly until you see a drop coming out, and then turn it off kind of thing. Shake it in there. No. Drop. Come on, drop. There we go. And it's going to take some time. And that's the beauty about chemistry. That's right about where we want it. Oh, I'll show you real quick. See that? Oh, just disappeared. You want the light pink color probably about 5 seconds. Okay? That's kind of what you want for as far as that color. It's kind of disappeared already, so we were pretty close on that one actually. And if you want, you could record the volume right now to see what it's at, write that down, and you could try another drop and see what happens. The only problem is, make sure that you know, after you add that other drop, you have to make sure you adjust it here to start when you're starting the next one, right? If it's not your last experiment here. I got one more drop here just kind of hanging on there. So I'm just going to use a little bit of water here, I think, and get that off of there. Water is not going to affect it. Okay, you're adding water anyway. So yeah, that was probably the drop that we needed. This was, you saw 1 drop was kind of clear. This is 1 extra, not even a real drop. So like I said, it's very hard to duplicate that right now because of indicators and the type of acid and base I'm using. So probably a little too dark, but that's okay. Let's take the measurement here. 15 point. I'd say 15.9-ish. And that's 5.2. Okay? So, what do you do with all this now? Well, we have the requirement for a titration is that we need at least 3 trials, which we have, and those 3 trials have to be within 0.2 milliliters of each other. Okay, they have to be in a range of 0.2. So are these 3 values here, are they within 0.2 of each other? All of them, right? So that's good. We could actually stop right now. Okay. Now, is that going to happen tomorrow for you? I don't know. Maybe, maybe not, right? It's going to be your first time, so maybe you're going to have to do a 4th experiment. That's okay. In fact, I would expect you to probably be doing 4 tomorrow. I'd be surprised if you get away with 3. Okay. So we're going to take these 3, and what we need to do now is average them. Okay. So we're going to average 5.4 and 5.3 and 5.2. And since I got 3 trials, I'm going to divide by 3, of course. Okay. Now, obviously, you know, I think most of us know the average of 5.4, 5.3, and 5.2. However, when you do this on a calculator, okay, the average is not 11. Yes? But the calculator told me it was. Yes, because you didn't use brackets. Okay? If you're going to do this on a calculator, you have to do that. Otherwise, it's going to do the division and then add the other two numbers on there, and it's not 11. Okay? So make sure the number makes sense. If they're all in the 7 range, then it should be in the 7 range. Yes? Okay? So the average here is 5.3. Yes? Well, we're going to put that here. I'm going to change it to liters, though. Okay? Now, why does the volume go there? Well, 2 reasons. Okay? First of all, I already have a volume here. 10 milliliters, right? That's the acid. So, makes sense. Where do I got to put the other volume? Well, here. It has to go here. Where else is it going to go? Okay? And think about it this way. Look, if this is my aliquot down here and that's 10 milliliters of acid, what's up here? Sodium hydroxide, right? On average, how many milliliters does it take to neutralize that? On average, it takes about 5.3 milliliters. 5.3, 5.3, 5.3, right? Well, technically 5.4, 5.2, and 5.3, yes, or whatever it was, 5.3, 5.2, okay? But on average, it takes about 5.3 milliliters of sodium hydroxide, 5.3 milliliters of sodium hydroxide to neutralize that acid, okay? I got C and V, I can find N, right? So it works out to be 0.00053 moles. I can move that over, right? If I had 0.00053 moles, well, of base, I probably had to use 0.00053 moles of acid, right? It's a 1-to-1 ratio. So for every mole of hydrochloric acid, I need a mole of sodium hydroxide to neutralize it, right? So if I have 0.00053 moles of sodium hydroxide, I need 0.00053 moles of hydrochloric acid, right? Divided by 0.010, and N divided by V here will give you 0.053 moles per liter. Final answer. Okay? So we've done our titration to find the missing concentration. Okay? Now, by the way, how accurate is this? Well, I can tell you right now, it's accurate, very accurate. This is, I tried to make 0.05 and I eyeballed it a little bit, so I'm not going to lie to you. So it could be actually right on the money. But I tried to make 0.05 molar hydrochloric acid, so we're off by 0.003 of a mole per liter. Okay? If you do the percent yield, percent error on that, which we'll talk about on Friday, you'll see that that's pretty close. Okay? There's probably less than 1% error. It's very, very accurate, guys. When you're going drop by drop, it's very, very accurate. Yes? Okay? So, that's what you're going to do tomorrow. All right? Now, things can happen. So, what happens, or on a quiz or test, what would these questions look like? Well, obviously, I can't get you to do this for a quiz or a test. I need to give you some numbers, right? So I'll show you what that looks like in a second here. But tomorrow, you might get, for example, let's say 7, 7.1, 7.2, and 7.4, for example, as some experimental numbers, okay? Once again, you need at least 3 that are within 0.2. So if you look at this set of numbers here, you would be averaging these 3, yes? Right? Because the 7.4 is within 0.2 here, yes. But 7.4 to 7.1 is too far of a spread, yes? So you cannot use this one as your average, okay? Only 3, at least 3, within 0.2. And the only ones that are within 0.2 are those 3 there. So you would not use the last one, okay? If you got these numbers here, let's leave it like this, okay? So let's just say you get 4 experiments. You might say, why would I do 4? If I got the first 3 there, I'd probably stop. Well, true, you probably would, okay? But if you get a quiz or a test question based on these numbers here, what do you need to average? Well, at least 3 within 0.2. These are all within 0.2, so you would have to average all 4 of these, yes? Okay, so you would average all 4 because they are all within 0.2, okay? What happens if you got numbers like this? Now, this is probably not going to happen to you, but I'll just tell you a little bit about this. Let's say you get these numbers here. Okay, let's say you're a little bit exuberant and you decide, hey, I'm going to do more than what I need to do. I'm going to do 5 experiments tomorrow just to make sure I'm very accurate. Hey, which I like, by the way. Which numbers do you take now? Well, those are within 0.2, right? Yes. But since you decided to be very accurate, the problem is, so are those within 0.2. So which set of data do you take? And the answer is neither. You, for your reward, get to do another experiment. Because you don't know which set, I don't know what set to use. Is there a difference between averaging these and those? Sure there is. You might say, why don't I just average all of them? Well, that'd be the nice solution, but you can't. Because the rule is they have to be within 0.2. Have to stick with that. So what you would have to do is another experiment. And then if you got 7.2, for example, then I'd say, hey, let's average those then. Okay? Then you would know which ones to go with. You would take those and you would average 1, 2, 3, 4, 5 of those. Okay? Remember, on a quiz or a test, you will not be doing this part here. Because that's part of the experiment, right? So you don't have to worry about that on a quiz or a test. You will have to worry about this. So when you get to this part here, you need to find the ones that are within 0.2 and average as many as you can. At least 3 of them, of course. Okay? Make sure, because this is where you're going to get tripped up here. If you don't average the proper ones, this volume is off right here. And if this is off, then this is off. And if that's off, and that makes that off, and you get the wrong answer. Okay? So even though you might know everything else that's going on here, you are going to be off. Okay? So be careful, okay, when you average those numbers. They have to be at least 3 within 0.2. If you got 4, you got to average 4 of them within 0.2. 5, average 5. If you get 10 numbers and they're all within 0.2, you got to average all 10 of them. Okay? But they have to be within 0.2. So keep that in mind when you're looking at these kinds of numbers. And tomorrow probably not going to be a big deal for you, but on a quiz or a test, make sure you know that. Okay? So today, you guys have 2 practice questions I want you guys to do. They're on the last sheet here for you. Just number 1 and 2. And once again, okay, take a look at those. The first thing I would suggest, of course, is you need to write out the equation. And of course, balance it. Okay? So take a look at number 1, write out the equation, balance it, put the information in the right spot, right? What are you looking for? Which concentration do they give you? You're looking for the other concentration, yes? So keep that in mind when you're doing these questions. So just 1 and 2 for tomorrow. We didn't go over your sheet from yesterday, which was solution stoichiometry, and I know that. We're almost out of time, but if there's any questions, we can definitely do that as well. Okay? So if there's anything with that, let me know. If we get done early enough tomorrow, we might be able to have some time for that. Okay? All right.